Hi everyone, we are from PS Modern College of Engineering Pune, Department of Electrical Engineering. We are presenting this project on an intelligent battery optimization system in electric vehicle. My name is Pratik Mali with my team members Rutvik Jadhav, Aniruddha More and Kiran More under the guidance of Professor S.N. Safekar. The aim of our project is an electric vehicle project that increases mileage of electric vehicle using battery saver technology by reducing energy consumption in secondary loads. Talking about the objectives, design and develop a smart battery optimization system that enhances the efficiency of electric vehicle by dynamically adjusting various parameters such as voltage, current and temperature based on Arduino and Atmega 328U microcontroller.
So what are the major difficulties in EV sector is the charging capacity of the EV vehicles and the range of the EV vehicles to charge that extended battery. So this best solution for this is battery saver mode, which we have developed a prototype which increases the mileage without compensating the essential features like safety and convenience.
Now let us take short review on the prototype and component used in it.
The main component is Arduino Uno board, which has Atmega 328U microcontroller IC connected to it. Another component is lithium-ion battery, which has 12 volt 2 ampere supply, LCD display 16 by 2. Then we have secondary load connected to it, LCD, buzzer and DC fan. INA 219 sensor is connected, which senses the current and voltage of the battery. L298 microcontroller drive is connected for speed controlling of DC motor, which has 300 RPM.
Now let us see the block diagram of our hardware. First of all, there is an input side where battery pack supplies power to the DC motor, and state of charge of the battery is sensed by the battery sensor, and this signals given to the Atmega 328U, which is our heart of our project prototype. Then there is output side where we connected lights, fans, dashboard and buzzers, and output signal of Atmega 328U is given to the L298 motor drive, which control the speed of the motor to control the speed of our vehicle, and LCD display is given to see the state of the charge of our battery pack.
As you can see, at battery percentage of 60%, our power mode 1 is turned on. In this mode, our highest power consuming secondary load, that is DC fan, is turned off, while other secondary load is turned on, and our primary load, that is DC motor, is running with 100% efficiency, that is 300 RPM. At battery percentage of 50%, our power mode 2 is turned on. In this mode, our second highest power consuming load, that is LED, is turned off with DC fan, which is already turned off, and our primary load, that is DC motor, is running at 50% efficiency, that is 150 RPM. When battery percentage is at 40%, our power mode 3 is turned on. In this mode, all the secondary loads are turned off, while the primary load, that is DC fan, is running at 150 RPM, that is 50% efficiency.
Let us see the result table of our project. Talking of the result table, on our left hand side there are primary load as well as secondary load, DC motor, DC fan, LED and buzzer. When our battery voltage is at 60%, our DC motor is turned on and with full efficiency of 300 RPM, and our DC fan is turned off, while LED is on with full intensity and buzzer is also on with full efficiency. In power mode 2, when our battery percent is at 50%, the efficiency of the DC motor is reduced by 50% at 150 RPM. DC fan is turned off as it is. The LED is also turned off and the buzzer efficiency is 100%. When power mode 3 is turned on at 40%, the DC motor the DC motor is turned on at 150 RPM, 50% efficiency. Our DC fan is turned off as it is. LED is also turned off as it is. The buzzer as well is turned off as it is. As discussed earlier, when the battery voltage is at 100%, normally primary and secondary both loads are turned on. At the discharge time of a battery is 5 hours. When the battery voltage is at 60%, power mode 1 is turned on. At this time, this discharge time of battery is 6%, power is saved in this mode, and the time of battery discharge is increased by 20 minutes. When battery percent is at 50%, power mode 2 is turned on. In this, 12% power is saved and discharge time is increased by 50 minutes. When battery voltage is at 40%, power mode 3 is turned on, 15% power is saved, and the discharge time increased by 1.5 hours.
From this prototype, we can conclude that 10 to 20% battery is wasted in our HVAC system. If we manage that system in an effective way, we can save up to 15 to 20% of battery discharge. In our project, we have saved and increased the date of discharge to 2 hours.